Hello, a very good morning to all. We have already started with the third chapter, that is Steam and Steam Boiler, the 14 marks weighted chapter. And in the previous lecture, we have seen how the formation of steam takes place. So before this, we have seen what is the concept of sensible heat and latent heat. So in just few minutes, we will see the flashback of our previous slide. So we have seen what is steam. It is nothing but the vapor of water and is invisible when pure and dry. It is used as working substance in steam engines and boilers as well as turbines. Then we have seen this concept of sensible heat and latent heat. So whatever the temperature, if we can measure that heat with the help of thermometer, or if the heat is measurable, then we call it as sensible heat, whereas the heat that is responsible for changing the phase of the system, then we call it as latent heat. So we cannot measure this latent heat with the help of thermometer. So these were the points related with the types of heat. And then the most important part from our previous lecture, that is formation or generation of steam, where we have studied the 5 regions or the 5 stages of heat addition. So the first stage in which that is region A to B, where we have seen that we have considered the ice which was at minus 10 degrees Celsius, and in first stage this ice is converted, or its temperature is increased to 0 degrees Celsius, and during this entire stage the ice or the system is in solid state. So again, after this stage, the second stage represented by line B to C. So during this stage, if we at point B, if we are adding a certain amount of heat into the system, then there will be no any rise in temperature, but instead the solid phase will start converting into liquid phase. So there will be change in phase during this stage, and thus we call it as latent heat of fusion. After this stage, the next stage is represented by line C to D, which we call it as the sensible heat addition. So again, during this stage, we can see that there is sharp rise in temperature, as whatever the heat is added, it is utilized to increase the temperature of the liquid which is formed at point C. So thus during this stage, the temperature of water will be increased from 0 degrees Celsius to 100 degrees Celsius, that is at point D. Now again, if we further add heat to the system, then the next stage, which is represented by line D to E, that is with further addition of heat, again there will be no any rise in temperature, but instead the liquid phase will be converted into gaseous state as the heat is added. So we call this region as latent heat of vaporization, and at point E we will be having saturated steam. And again, the last stage, that is if we further add heat to this steam, that is at point E, where we are having saturated steam. So if we try to further add heat to the system, then again the temperature will go on rising, and thus we can see in the diagram that there is sharp rise in temperature. Thus from point E onwards, so whatever the heat we are adding, it will be responsible for rising the temperature of that steam. And we know that we call this steam as a superheated steam, and this superheated steam is very important for several applications, such as for power generation with the help of turbines. So this was all about the formation or generation of steam at constant pressure, which we have studied in our previous lecture. One more important point that you should know, this figure which we are having in this slide, it is also known as TH diagram. So along with this TH diagram, we have also studied what is the TS diagram, that is temperature versus entropy. So again, in this diagram, we have just taken the entropy on x-axis and temperature on y-axis, and we have studied the bell-shaped curve. That is, it is consisting of two lines. So one is the saturated liquid line, represented by curve A to E, and E is the critical point. And from E point onwards, the curve is called as saturated vapor line. Again, we have seen the three regions. That is the left region of saturated liquid line, we call it as liquid region. The right hand side of this diagram, that is the region beyond saturated vapor line, we call it as vapor region. And whatever the region is available below the curve, we call it as wet region, which is indicated by the letter L plus V. So this was all about the TS diagram. So now we will start with our today's lecture. So in today's lecture, we are having most of the definitions. So it will be just like a theoretical lecture. So we'll be starting with the various conditions of steam. It is nothing but we can simply refer it as what are the several types of steam. So we will study this. So first we will study what is the meaning of dry saturated steam. So if the steam does not contain any moisture, then we call it as dry saturated steam. It contains just sufficient heat energy to maintain all the water in the gaseous state. Or in other words, we can simply say that the minimum amount of heat which is required to convert the entire given quantity of water into 100% gaseous state. So we can call it as a dry saturated steam. So after this, now we will see what is the meaning of wet steam. So again, if the saturated steam contains certain amount of liquid particles in it, then we call it as wet steam. These liquid particles are generally called as moisture. So if the steam is containing some moisture content, or if it is having certain liquid particles, then we call it as wet steam. After wet steam, again we are having another type of steam which is called as superheated steam. So if the temperature of the steam is greater than that of boiling point, corresponding to the pressure of the steam generation, then the steam is called as superheated steam. So we have also studied regarding this superheated steam in case of TH diagram, when we were studying how the formation or generation of steam take place. So in that we have studied the last portion or the last stage of heat addition, which was I think represented by line E to F, where we have shown the superheating process. So after point E, where we were having the saturation region, that is saturated steam. So with further addition of heat, there was a rise in temperature. So whatever the heat is added to the steam after its saturation point, then we call it as superheated steam. So these are the conditions or the types of steam. Apart from this, there is one more important definition related to the condition of steam, and this is nothing but degree of superheat. Most of the times in MSBTE paper, they are asking this definition. So let's see what is degree of superheat. So it is defined as the difference between superheated temperature of steam and its saturation temperature. So we are having a mathematical formula for the same, that is degree of superheat. It is equal to the difference in superheated temperature minus saturation temperature. To understand this concept of degree of superheat, if we consider one example, say that if we are having a certain steam which is having temperature say about 150 degrees Celsius and at atmospheric pressure, Then we can calculate the degree of superheat as taking the difference between superheated temperature and the saturation temperature. So as the temperature we have considered as 150 degrees Celsius, so this value is nothing but superheated temperature. And since we have considered atmospheric pressure, that is 1.013 bar, so at this pressure the saturation temperature of steam will be 100 degrees Celsius. So to calculate degree of superheat, we will just take simply difference of these two temperatures, that is 150 degree minus 100 degrees Celsius. So we will be getting answer as 50 degrees Celsius. So this 50 degrees Celsius, it is nothing but we call it as degree of superheat. So we are going to see this in detail while solving the numericals, and that's the reason I have not mentioned all those points in this slide only. Now we will start with the new point, that is properties of steam, and we are going to study the three properties of steam, which are nothing but the enthalpy, entropy and specific volume. So as we have already studied what are the various conditions of steam, so accordingly we will also see all these three properties for all the types of steam. So first we will start with the first property, that is enthalpy. Now regarding enthalpy, we have already studied what is the meaning of enthalpy in the first chapter. So here we are interested in how to determine or what is the mathematical formula to calculate the enthalpy for various conditions of steam. So enthalpy of steam, it is nothing but the heat content in the steam. Now we will see how to calculate this enthalpy, or what is the enthalpy of dry steam. So the quantity of heat required to convert 1 kg of water at 0 degree Celsius into dry saturated steam at constant pressure is known as enthalpy of dry saturated steam. So this simply means that if we consider 1 kg of water which is at 0 degree Celsius and at constant pressure, then how much quantity of heat is required to convert this water into completely dry saturated steam, that is into gaseous state. So this enthalpy of dry saturated steam, it is denoted by Hg, which is shown in this slide, and the formula to calculate the enthalpy of dry saturated steam is given below, that is Hg is equal to Hf plus Hfg. Now you will think, what is the meaning of this Hg or Hf as well as Hfg? So if you remember our previous lecture where we have studied the TS diagram, so we are having here a screenshot of our previous slide where we have seen the various values of entropy, that is Sg, Sfg or Sf. So all these values we have obtained from the TS diagram. So similarly also we can obtain all the values of these Hg, Hf and Hfg. So these are the values of enthalpy which are obtained from either the saturated liquid line or from saturated vapor line, or we can obtain the value of Hfg from the wet region. Just like this above figure, you can see there was entropy on x-axis when we were studying regarding the TS diagram. So you can see that how we have determined or how to represent the value of SF, which is shown in this figure. We have calculated or represented the value of SF by extending the line from the saturated liquid line, as well as we can also see that SFG is represented in the wet region, that is where L plus V is denoted, and Sg, it is calculated from the saturated vapor line. So similarly then we can obtain the values of Hg, Hf and Hfg. So this was regarding the calculation part. Now we will see what is the enthalpy of wet steam. So it is defined as the quantity of heat required to convert 1 kg of water at 0 degrees Celsius into wet steam having dryness fraction X at constant pressure. So this is called as the enthalpy of wet steam, and it is denoted by H wet, or simply we can also denote it as H small w. So W will be at suffix. If we look into the given TS diagram, so we can observe that under the bell-shaped curve we are having the wet region. So in this wet region, you can see that we are having several values for x. So you can see in this diagram that is x is equal to 0.1, x is equal to 0.2. So the values of x is actually ranging from 0 to 1. Okay, so the value x equal to 1, this will be conditioned when the steam is dry saturated. That is curve, this dotted curve, it will be coinciding with the actual dry saturated vapor line. Thus, if we are calculating the enthalpy for wet steam, then it is very important to determine the value of this dryness fraction, which is denoted by letter x. So we can obtain this value from either graph or by we are having for some formula for calculation of this dryness fraction, which we will also see in the further slide. So now if we look at the calculation or a mathematical formula for the calculation of wet steam, then we can calculate this as follows. That is HW, enthalpy of wet steam. It is equal to HF plus X into HFG. So HF, this value we will be obtaining from the saturated liquid line, and X is nothing but the dryness fraction, and HFG, this value will be obtained from the wet region. So again, in case of HFG, we can substitute this value as Hg minus Hf. So with this formula, we can calculate the enthalpy of wet steam. Now we will see another type of steam, that is how to calculate the enthalpy of superheated steam. So it is defined as the quantity of heat required to convert 1 kg of water at 0 degrees Celsius at constant pressure into superheated steam. So we call it as the enthalpy of superheated steam, that is converting the water from 0 degrees Celsius to the temperature above the saturated steam. Again, this enthalpy of superheated steam, it is denoted by HSUP, and we can calculate this as follows. That is HSUP is equal to Hg plus Cp into T superheated minus T saturated, and again we can replace the value of Hg as Hf plus Hfg. Again, the remaining part of this formula, that is plus Cp into temperature difference, that is superheated temperature minus saturated temperature. So we are also having the meaning of each and every term which is involved in this formula. So Hf is nothing but enthalpy of saturated water in kilojoule per kg. Hfg is nothing but the enthalpy of evaporation or latent heat in kilojoule per kg. Hg, it is the enthalpy of dry saturated steam in kilojoule per kg, and Cp is the specific heat of superheated steam in kilojoule per kg Kelvin, and Tsup is nothing but the temperature of superheated steam in Kelvin, and again Sat is nothing but the temperature of saturated steam in Kelvin. So this was regarding the first property of steam, that is enthalpy, which we can calculate for various conditions of steam. Now we will start with the next property of steam, that is entropy, and just like enthalpy we will see how to calculate the entropy for various conditions of steam. So let's start with the first point, that is entropy of dry saturated steam. It is defined as the sum of entropy of water and entropy of evaporation. And this entropy of dry saturated steam, it is denoted by Sg, which is shown in the slide. And the mathematical formula to calculate this entropy is given as follows, that is Sg is equal to Sf plus Sfg. So we have now understood that how we are going to calculate these values, that is Sf can be calculated from saturated liquid line, Sg can be calculated with a reference to saturated vapor line, and the value of Sfg it can be obtained from the wet region. Also there is one more important point to note, that is we can calculate all the values of these Sg, Sf and Sfg, or in terms of enthalpy or a specific volume, that is all the properties of steam which we are studying in this lecture. We can calculate the all the terms which are coming in these formulas with the help of steam table. So right now I am not talking much about steam table, because still we are going to see that part in the further lecture. But right now you can just remember that we can obtain all the values which are given in this formula, that is either it may be Sf or Sfg or Sg, as well as in case of enthalpy we have seen HF, HFG or HG. Similarly also in case of a specific volume. So all these values we can determine either from the chart, or either we can use the steam table. So we will learn that part in the next lecture when we are studying the Moliere chart or the use of steam table. Now coming back to our point, now we will see how to calculate the entropy of wet steam. Thus for 1 kg of wet steam having dryness fraction as x, its entropy can be calculated as follows. So the entropy of wet steam is denoted by SW, and it can be calculated by using the formula, that is equal to Sf plus x into Sfg. So again we can replace the value of Sfg as the difference in Sg and Sf. So we are having a formula that is equal to S wet is equal to Sf plus x into Sg minus Sf. Again if we talk about the entropy of superheated steam, then for 1 kg of steam at superheated temperature, its entropy can be calculated as follows, that is SSUP is equal to Sg plus Cp into log to the base E, and the ratio of temperature, that is superheated temperature divided by saturated temperature. So if we look at all the three formulas regarding the entropy, and if you compare these formulas with those of enthalpy, then you can see that the first two formulas are almost similar, just we are replacing the value of H by S. Whereas if we look at the entropy of superheated steam, then there is a little bit change, that is we are taking the ratio of temperature, whereas in case of enthalpy, while calculating the enthalpy of superheated steam, we have used the formula as Hg plus Cp into difference of the temperature. So here just you have to note down this change, that is while calculating the entropy we are supposed to take the ratio of this superheated temperature and saturated temperature. So this is only a little bit change for the calculation part regarding the entropy. Now we will see the last part of the property of steam, that is specific volume. So specific volume, it is nothing but the volume of steam per kg. Then again we are going to study how to calculate the specific volume for various conditions of steam. and in that we are having first point, that is specific volume of dry saturated steam. It is simply defined as the volume of 1 kg of dry steam at given pressure. So this is denoted by Vg, and we can easily calculate this value of specific volume with the help of steam table. So we will directly get the value of specific volume of dry saturated steam from steam table, and so there will be no any formula for calculation regarding this part. Now the next term, that is a specific volume of wet steam, we can define it as follows. The volume of 1 kg of wet steam is equal to the volume of dry portion of steam plus volume of water in suspension. So actually the wet steam, it will be having some moisture content in it. So when we are speaking regarding the volume, we have to consider the volume of steam part, that is the steam which is dry, as well as we also have to consider the volume of water which is present in that steam. So we will take the summation of both these volumes, and then we will get the specific volume of wet steam. So again it is denoted by the letter, that is V wet, WET, and we can calculate this by using formula V wet is equal to X into Vg, and we already know that X is nothing but the dryness fraction, and the value of Vg we will be getting from the steam table. This was about the specific volume of wet steam, and the last part related to specific volume, that is the specific volume of superheated steam. We can calculate this as follows, that is V SUP is equal to superheated temperature divided by saturation temperature, and this ratio multiplied by Vg. So by this formula we can calculate the specific volume for superheated steam. So this was the last part from the properties of steam. We have studied the three properties, that is enthalpy, entropy and specific volume, and based on the conditions of steam we have studied how to calculate the various values of these properties by using these several formulas. So it is very important that you should remember all these 9 formulas, so that if any question is asked based on the properties of steam, then you can be able to solve these numericals.